Hey guys, Mr. Grant here with a quick video, a little bit of help for the word problems in Chapter 7, Exponential Functions. So the first thing that we need to be able to do is figure out which formula we're going to use. So anything that uses a percent, if you see a percentage symbol in the problem, it's going to be one of these two formulas. Now, if you only see a percent and you don't see the word compound, you're using the one on the left. If you see the word compound as well as the percent sign, you're using the one on the right. We're going to go through both of these and some keywords to help you figure out what numbers to plug in where, as well as an example of each. So for the one on the left, the basic interest formula, we have four things we need to determine with each one of these. What do we plug in for the lowercase a? Is it a plus or a minus? What do we plug in for the r? What do we plug in for the t? So keywords for what to plug in for the lowercase a. This would be a dollar. If there's a dollar sign attached to it, that's going to go there. Anything with population, really common populations we would talk about in these types of problems are things like bacteria and people. All of those would fit the criteria for that initial value, which is the lowercase a. Next, we need to determine whether or not it's going to be a plus or a minus. If it's a plus, it's anything that's going to tell you that it's growing. So words like interest, appreciate, accrue, earn, grow up, increase. These are all words that are telling you that it is going to be a plus. It's increasing over time. Decreasing over time would be things like depreciate, decay, lose, down, decrease. Other words as well, anything that would tell you that the value is going down over time. The R is your percent rate, and you must convert this to a decimal for this to work. So for example, 4%, you wouldn't plug in a 4, you would plug in a 0.04. So you either need to divide by 100 or move the decimal place twice. And the last thing is T. This is going to be however many units of time you've gone, something like year, month, week, anything that tells you there's a certain amount of time that has elapsed. Okay, so our first example, number of bacteria present in a colony is 180 at noon, and the bacteria grows at a rate of 22% per hour. How many will be present at 8 p.m.? Now, I've got a percent here, but no compound in sight, so that tells me that I am using this formula, the simple interest formula, the basic growth or decay formula. All right, so the number of bacteria present, so bacteria, that tells me that is what I'm going to use for my initial value. So this is a population problem, a population of bacteria. Then, is this a plus or a minus? It grows, so that means this is going to be a plus. What is my rate? It grows at a rate of 22%. So that is going to be, now I can either say 22% and move the decimal place twice, which it would be here at the end of the number. And so that would make a 0.22. Cross out that other one. Or I could do 22% divided by 100, plug it into my calculator, and I'll get 0.22. Either way works. So 1 plus 0.22. And then T, it's going up by 22% per hour. So how many hours are here? We're starting at noon, and then we're ending at 8 p.m. So that's 8 total hours between noon and 8. So that'll be my exponent. Now, you can plug this into your calculator just the way it looks. However, you are going to be asked to understand and recognize that this is the same as 1 plus 0.22 is the same as 1.22, that these are both the same thing, that you could simplify the first one, actually add the 1.22 in parentheses and rewrite it like this. That's going to be important on the test that you recognize that. All right, so now if you try plugging this into the calculator, you should get 883 if you plug it in correctly. Okay, moving on. So now our compound interest formula, a little more complicated looking, but it's again just deciding what number goes where. All right, so P, that capital P, your principal value, that is always a dollar amount. So whatever number has a dollar sign in front of it goes there. The R, again, is your percent. Whatever has a percent next to it, just convert it to a decimal and plug it in for R. N is, it goes in twice, and this is probably the toughest one for students. It's a word that tells you how many times per year something compounds. So these are really the really common ones that you could see in this chapter. Would be annual, N would equal 1. Semi-annual, it would equal 2. Quarterly would equal 4. Monthly would equal 12. Weekly would equal 52. There's others as well, but this is going to be like 99% of them. And then the last thing, that T is going to be in years. All right, so let's do one last example. All right, so my retirement account is currently worth $5.53. It earns 3.2% interest compounding monthly. How much will it be worth in 5 years? So let's take a look here. The dollar sign, 553, that tells me that that is what I'm using in place of that capital P, so 5.53. These are always a plus. The rate is 3.2, so I could either take that 3.2 and move the decimal place twice, putting a 0 in for any missing like values there. Or I could do 3.2 over 100, enter that in the calculator, and I'd get 0.032. So 1 plus 0.032. And this goes in there twice. I'm looking for that key word, things like monthly, weekly, daily, quarterly. In this case, it is monthly. And if we go back to the chart from the previous slide, it said that monthly was 12. Also, there are 12 months in a year, so there you go. Now that goes in there twice, right? Goes in the bottom of that fraction and one part of the exponent. And the very last part, T, is the number of years. So 5 years, and we'll plug that in. Now this one you don't have to simplify, just plug it in the way it looks. And if you do that correctly, if you want to check, you should get that my retirement account 3 years from now will be worth a grand total of $6.49. Right, I hope this was helpful. If you have any questions, be sure to email your teacher.